We will explain how Eratosthenes calculated the circumference of the Earth. Eratosthenes knew that on the summer solstice in the town of Syene in southern Egypt, there was no shadow at the bottom of a well. He realized that this meant the sun was directly overhead in Syene at noon on that day each year. However, he knew that the sun was not directly above Alexandria on the summer solstice, and this was shown by the Tower of Alexandria. There was a shadow at the tower. He measured the angle between the shadow and the tower, and the angle was 7.2 degrees. 1/50th of a circle is 7.2 degrees, which meant that all he had to do was find the distance between the two cities, then times it roughly by five, roughly giving him the circumference of the Earth. Pharaonic bookkeepers at the time said that the distance from Syene to Alexandria is about 5,000 stadia. This information was checked yearly to make sure it was correct. However, the information he gathered was inaccurate in certain ways. First of all, many people believe that Eratosthenes would have used the Olympic stade, measuring in at about 176.4 meters, which would have given him the circumference of the Earth measuring at about 44,100 kilometers, which is about 10% of the real circumference of the Earth, the real circumference being 40,075 kilometers. The reason he got his calculation partially wrong was because he believed that Syene was on the Tropic of Cancer, and also that information that at the time had it written that there was 5,000 stadia between the city of Alexandria and the town of Syene, which was unfortunately wrong. A recent calculation was done in 2012 by Anthony Abreu-Morat, stating that with more accurate information at his disposal, Eratosthenes would have calculated the circumference of the Earth to 40,074 kilometers. This is just 0.16% away from the actual circumference of the Earth, being 40,075 kilometers. Mainly because the Earth isn't a perfect sphere. That's probably the only reason why he would have gotten this wrong. Thank you. On to the point here, which is represented as Syene. There is quite a substantial shadow here, as you can see here, at Alexandria. This means that with no shadow being at Syene, there was quite a substantial shadow at Alexandria. Now Eratosthenes asked himself, how could it be that there is no shadow at Syene and quite a substantial shadow at Alexandria? The only way would be that the Earth was round.